Okay. Thank you very much for all the attendance here, to the audience, also to the people who is following us streaming online, yes. Also to our four speakers that we will introduce later on, and also to the co-moderator. First of all, I'm going to introduce myself. This is Pedro Perez. I work at CINEA. I'm a project officer in the CCAM sector. I'm very pleased to co-moderate this session of CCAM enablers with my colleague, Margriet, that she will be taking over the continuation of the session after the presentation of the speakers. She will be moderating the Q&A. Later on, and well, I pass her the floor before starting with the introduction of this session. So, Margriet.
Thank you. Margriet van Schijndel from Eindhoven University, and within the CCAM partnership, leading the cluster on key enabling technologies. So I was quite eager to see what these projects are going to deliver, actually.
Okay. Any other message to the audience, or this is fine? Everything. Before.
Oh, give me the microphone. No, sorry. Well, when we started actually discussing key enabling technologies, when we started the CCAM partnership, it for many people felt like, oh, this is far away. This is almost rocket science, like those geeks working on things that we don't understand. But now things are getting together. Now you see with the projects that we see here on stage that it's becoming a reality, and that's very nice, I think. So I hope you're eager to hear those contributions as well.
Okay, thank you very much. Yes, indeed. I don't know how can I deal with this. Is the green one? Oh, okay, good. Yeah. So thank you very much, Margriet. Indeed, this session. This is actually the CCAM enablers, and these are the technologies that are needed to make the CCAM happen. Well, actually, it's part also, or the main topic within the Cluster 5 of the CCAM partnership, which is the key-enabled technologies. And actually, this is one of the main parts that will allow the autonomous vehicles to integrate them into the transport systems. There are, as you can see, three key areas that actually proposed to the European Commission, and actually the projects that our speakers are going to introduce today, they address all of them. Cybersecure and resilient CCAM, more powerful and reliable onboard perception and decision-making technologies addressing complex environmental conditions, and artificial intelligence explainable and trustworthy concepts, techniques, and models for the CCAM. Aspects that mainly several of the projects today that are going to be mentioned, like artificial intelligence, big data, and cybersecurity. These are actually essential parts that, as I said, our speakers today will address during their presentations. Well, indeed, I asked our speakers last week to provide a sentence about the projects that are going to introduce, how they contribute to this particular area. The first speaker said that the project contributes to be a CCAM enabler by providing a security and protection layer to the CCAM systems, which is crucial for increasing the trust in CCAM and hence to foster its adoption by the society. So the first project that we are going to see today, the results, the improvements on this respect, is SELFY. Buona tarda. Fanny. She is our the coordinator of the project. She's the head of the EU funding program for mobility and transport in Eurocat. You have a business administration specialized in logistics, supply chain, and international trade. You are also postgraduated in sustainable maritime and coastal management. And what actually I found there, and I was very curious to know about this, you have a technical certificate in meteorology.
Yes, I do. Yeah.
And what is the relation with this?
Yeah, well, you know, when you start research, everything is interesting. So I started by many fields.
Yeah.
And, well, somehow we find some relationship between these different areas, you know.
Okay.
But I see that you have quite a lot of information about me.
Well, okay, thank you. I do my best. Well, okay, remember you have 15 minutes for the presentation.
I remember.
And then I remind the audience that they can actually to ask you something about, well, the information they are going to show today.
Of course,
If they want to have any clarification. Otherwise, we will continue. So the floor is yours. Thank you very much.
Thank you,
And a
Pedro.
big applause for her, please.
Thank you very much for this introduction. Yes, so here we are going to talk about a very important technology enabler, which is the cybersecurity in the CCAM. You will see that it's really important. I'm going to present the SELFY project, which I am the coordinator. The SELFY project, a few information, quick information. As you will see, we are 14 partners with different kinds of profiles from industry, cities, research, and others. We started in 2022, which means that we are finishing in 4 months. So we are now in a very interesting period, which means that we are developing, finalizing the developments, and also starting the validations and demonstrations. What SELFY is about? SELFY is going to build the tools for a cybersecure and resilient CCAM. It's a key issue because the cybersecurity, as you all know, every object that is connected is raising some important risks at cybersecurity levels, and we have to anticipate, especially in the CCAM. So SELFY is going to develop a set of tools, which is comprised within a toolbox. In this toolbox, we will see 3 of the main pillars of the project. The first one, first of all, what we need to understand is what is happening, the situational awareness and the perception, especially when it comes about vulnerabilities or attacks. We will see that a bit later. The second one is very important too, because once we detect a vulnerability or an attack from a hacker in any part of the system, we have to act. So we have to protect the system, protect the people also. And the third one is one of the most important too, because it's the trust data management system. We are also needing to be able to share the data in a protected way. I will come back to these 3 macro tools because I will show you some results about them. So before showing the technical results, just a quick slide showing some important activities that we've been doing during the project. As you can see, we gathered quite a long list of requirements for a cyber-secure and a resilient CCAM system. We also selected 42 main standards. By the way, we saw that we need also to work on standardization. Not all the standards fit in this story. And we have selected a few use cases. We will see one of them, a set of tools that compose these 3 macro tools. And finally, I would like to invite you to see our website, but also the YouTube channel, because we've been uploading a lot of videos there. So you will see that. Right now, as I said, we are almost in the end of the project, which is a very interesting period because we have to validate everything. From one side, we have some tools that are validated in laboratory, others by simulation, such as algorithms and so. But we also have a real-world validation, which is important. It will happen in both sides. IDIADA from one side, with some vehicle coming from a virtual vehicle in Austria, and also in the city of Vienna, because city of Vienna has an area with some roadside units already connected, and we will integrate them with our own tools, and we will see how it works in terms of situational awareness. So let's go for the first video, which is going to explain you a bit more how we are working on the perception. This is a tool that was developed by CEA. You will see the video, which is quite
fusion and knowledge
explainable
detection tool from CEA is to integrate data from smart cameras and range sensors, such as LiDARs, to create a unified vision of a roadside unit's surrounding environment and send this information to the threat evaluation tool. Data received through the Cooperative Intelligent Transport System are also processed by the tool to discern anomalies. Focusing on the fusion of data from the RSU sensors, the tool can handle any number of sensors that either produce point cloud detections, like radars or LiDARs, or objects such as smart cameras. More precisely, point cloud detections are projected on a 2D occupancy grid representation, and a dynamic clustering algorithm is used to generate object detections. Pairwise association of objects is then performed for objects simultaneously detected by the RSU sensors. This example is from a real-world dataset provided by Canon. In this video, smart camera detections are in red, while the LiDAR detections are in blue. White labels are the result of fusion. The association performs well even when objects, here a vehicle and a pedestrian, are very close together. This example shows the value of combining smart cameras and LiDARs. Smart cameras are capable of high-quality object classification, while the LiDARs improve the accuracy of position and speed estimates.
This is how
Data
it works.
received
Let's
through
see
the
an attack
Cooperative Intelligent
running
Transport
by a
System
hacker.
are also processed by the tool after time delay compensation. All communications with the threat evaluation tool employ an objects listing ROS message. In the next video, we look at the output of the fusion module when an ITS message has been received. In this scenario, we assume that a cybersecurity attack is ongoing and that the RSU receives false information. On the right, a false ITS message states that a pedestrian has been detected, while on the left, he is absent from the scene. While the objects that are perceived by the RSU sensors are correctly fused, we see that the object corresponding to the phantom pedestrian is simply sent back as an unfused object. The threat evaluation tool will therefore be able to detect the anomaly.
So that was an example of the tools that we have in the perception block, which is really important for us. But now I would like also to explain you what happens after, okay? We are going to see another tool, which is the second video. I'm going to explain it myself. The second video is about the anomaly detection and mitigation. Here we are talking about the product which is called Artificial Immune System, which is developed by Eurecat. It works like a human body. We have the immune system that detects a virus, in this case it's a malware, and is able to autonomously create a protection against this attack. So as you can see, it's a tool that is based on machine learning, self-learning, and self-healing capacities. And we will see some examples. I will try to explain as much as possible. These are a set of screens. I will explain it a bit later. The AIS, the Artificial Immune System, is distributed among all of them. Here we have a roadside unit, here in this side. Here we have the VSOC, the Vehicle Security Operations Center. The AIS is running and is trained to detect any anomaly in the system. As soon as it detects an anomaly, and you will see here in this part of the screen that there is a hacker attacking the system here, the AIS will detect an anomaly and will analyze it and send it immediately to the roadside unit. That roadside unit, if it knows already that threat, it will be able to autonomously manage the risk and even put an action in place in the street. If not, it will send the information to the VSOC, and the VSOC again will learn from that attack, put in place some actions, such as, for instance, lowering the speed in all these areas. So this is an example of the tools that we have in the healing and protection part. And I would also like to show you something else, because I think it's really important, especially for the adoption by the society of the tools, which is the third video. It's quite a short video, but it's, I think, self-explainable. How should we protect the data in all this world? So here we have a tool that has been developed by Ficosa, which is a tier 1, which is based on machine learning too. So normally there is sound here. If you could just, yeah, perfect. And you will see how it works.
Vehicle sensors can record sensitive personal data. For this reason, in Ficosa ADAS, we have developed data anonymization tools that are based on AI algorithms that protect data privacy and respect the EU regulations.
This algorithm is specifically designed to detect sensitive information, in particular license plate and faces.
To adhere to the European regulations, Ficosa has developed an anonymization algorithm that operates in real time with minimal computational resources. This algorithm is specifically designed to detect and anonymize sensitive information captured by vehicle-mounted cameras, namely faces and license plates. Ficosa's team has developed a deep learning algorithm that detects pedestrians' faces and vehicles' license plates. To be able to protect this sensitive personal information by anonymizing it, Ficosa's team created a dataset consisting of images captured by the vehicle's onboard cameras. By using our own dataset, we ensured that the model learned from relevant and context-specific data.
Okay, so these are just examples of the tools that compose these 3 macro tools. So I'm really happy to be able to invite you to check our YouTube and also channels like the website, because you will see others. And here the idea is to integrate all these tools for the sake of the cybersecurity and resilience. Apart from this, we also achieved some other kinds of results, such as the social one. I would like to highlight it because it's quite interesting. We did a study to see how is the perception of the society on the cybersecurity in the CCAM. And we discovered, thanks to like 80 associations dedicated to vulnerable groups, for example, impaired people, elderly, and so, that their perception on the cybersecurity is quite different from the general public. In their case, they look quite closely to the cybersecurity itself and the accessibility, while the general public gives much more importance on the protection of the data, so the privacy. So this is also something interesting that we got and we implemented in our developments in order to be sure that we were taking into account this by adding some layers without complicating the usability, of course, of the tools. So we have all these tools. Very soon we will be really happy to show you the real images of the real world. And I would like to show you what kind of impacts we are expecting from these kind of tools. We are, of course, talking about a technology enabler for the CCAM, but I think it's much more than this, because indeed it's a must to make it work and to be sure that we are not causing accidents or provoking disruptions. And of course, as you could see, that 3rd pillar, which is dedicated to the trust, I think it's super important to have it here also, because if we do not have this, we will not have the adoption by the society. How are we following these objectives and making it possible to get these impacts? I'm not going through the slide, but just very, very quickly for your information. We have a certain number of KPIs. The ones that are on the left side are quite operational, and they are basically considering the robustness of the system. The robustness, for instance, in terms of speed of detection of a problem, speed of reaction against this problem, and also the accuracy of the detection, of course. If we are able to consider all these KPIs, we will be happy to say that, okay, SELFY toolbox is reliable and is robust. From the other side, we work quite a lot together with other projects. We've been working, for instance, with the Connect project, which is our sister project, also with FAME and others. You have the list there. It was really interesting because we've been sharing quite a lot of information in terms of selection of use cases, user requirements, standards, and so. And last, when we will finish this real-world validation, I think we will be quite ready to upscale our results towards a larger scale demonstration. We could upscale, indeed, the full SELFY toolbox, but we could also upscale part of the tools that comprise the SELFY. However, we have to consider important things here. We will shift from a few elements, 2 vehicles, 1 pedestrian, and so, to many more informations and devices. Also, the VSOC should be upscaled to receive many more instructions and requests per second. So we have to be sure that the SELFY is really strong enough to be assuming that. Of course, we have the regulations, we have the standardization, we have all these things that we have to talk about. I just want to highlight one, which is the liability. What happens and who is liable if we have an attack in the ecosystem of the CCAM, not just in the vehicle, but it could be in the infrastructure. And finally, my last sentence is that as soon as we have this SELFY completely developed and also demonstrated in larger scale, we will probably have to do like in similar other domains, such as the banking, the energy, and so, which is creating another top layer of security, which would audit some tools like the SELFY one, because the SELFY by itself cannot be working without another audit on the top. That's it from my side. Oh, this is my alarm. I was hearing a noise.
Yeah, okay. Thank
I
you.
didn't see your red flag.
No, but actually you have the clock there. So no, don't leave yet. Thank you very much, Fanny. A big applause for her, please.
Thank you.
I think it's a very interesting information that you provided. You said now you are in the validation process,
yes,
which is fine. And actually, now you have the chance to invite the people for the final event that you are planning.
Yes, indeed.
Okay.
Indeed. We are going to organize our final event during the EUCAD event in Ispra. The date is on the 12th, so it's just before the official start of the EUCAD, but it's from 5 to 7 in the afternoon, evening. So for those who will be able to come the day before, we would really be happy to show you the final results of the project. Thank you for reminding
Okay,
us.
no. Thank you very much to you. Thank you very much for the presentation. For you to know, I'm the project officer of this particular project that actually I'm following very, very carefully, because I think this is actually a very nice area that actually has to evolve in the future,
yeah,
to guarantee the cybersecurity of the CCAM communications. So thank you very much again, and I go now with the second speaker. And the second speaker, the sentence that provided, it was that the project serves as a CCAM enabler by establishing a harmonized methodology for the development and testing of artificial intelligence-based CCAM solutions. Moreover, this project ensures that artificial intelligence systems using CCAM meet the highest standards for vehicle drivers, function developers, and certification legal bodies. The project is AIthena, and I see Arachaldeon that Ollana already, took her place.
Yes.
She's the head of ITS and engineering at Vicontech in the Basque Country in Spain. She's an expert analyst concept developer of ITS CCAM solutions based on computer vision and machine learning. You hold a PhD with honors cum laude in telecommunication, even if maybe it's far away, when you got it. And what I found, and actually I think you're a pioneer on this. Yeah. What is I say Galileo?
Okay, yes.
Oh, yeah,
yes,
okay,
yes,
because you know that Galileo was launched in December 2005, but you were before, from October 2003 up to May 2007, to develop several algorithms and modules for satellite navigation, which actually include also Galileo. So you are actually a real pioneer on that. And what can you tell briefly about the origins of that?
The origins was my PhD thesis at Fraunhofer Institute, and I was researching on algorithms. And then after doing my PhD, I returned back home, and then I applied what I learned there to other domains like the automotive.
Okay, perfect. So very pleased to listen to you, the information that you are going to show regarding the AIthena project. So a big applause for her. Thank you.
Okay, so thank you very much for the presentation, and I am here to be the first project with the sister project AI for CCAM to present this quite important topic on AI, given the current situation with the AI. So the idea of the AIthena project somehow is that AI is a challenge. So bringing AI into the automotive sector is a challenge, because with the AI, with the new algorithms, what we are facing is that we don't understand what is going on, and still it gives opens a lot of opportunities for dealing or doing complex things that with regular algorithms we cannot achieve. So we need to bring these two things together and see how can we make this work for the automotive sector. So the idea of the AIthena project is, how can we bring a harmonized methodology in order to all people to have some kind of standards to address how to prepare, design, develop, and test this kind of AI having modules functionalities for CCAM, which means that in the project we are covering different types of applications, like from perception to traffic management. So for that, we are focusing on the trustworthy pillars. Accuracy, explainability, accountability, privacy, and ethics. And we also understand that it's not only for developers. So the AI, and going through the AI certification process, the AI needs to be accountable for a lot of different kind of users. So we need to focus on how to make it accountable and understandable for different type of users. So this is what we have. And to do this, we are focusing on three main pillars, which is data, AI models, and testing. Why? Because in these algorithms, what we are using are somehow neuronal networks that are trained with data. So we need to really work on these areas if we want to have an harmonized approach. So what are we proposing, and which were our objectives? So first of all, as I have said, so come with an harmonized approach for helping everyone that is developing, testing an AI-containing solution for the automotive sector. So our main goal is to have an harmonized methodology. This methodology, as I said before, needs to be user-centric. And user-centric means that it's for developers, it's for certification bodies, it's for data engineers, it's for the end user, and it's for the people that want to deploy that. The approach should also have from the very beginning the idea that the AI process usually is not something that I develop and is going to be static for the rest of the life, but there are retraining processes, there is new data that it needs to be input, so we need to have some kind of accountability of the whole process. So the second main objective is how to have this kind of framework that we can have the accountability of what has been going on within all this AI approach. Having that into account, the main pillars. So how to have the explainable AI models. So explainability or trust-based based on performance, process, and purpose of the algorithm. So we are generating algorithms that are going to be focusing on that. The next pillar is data. So how to characterize the data that we are using to train those algorithms, because the data is going to be one of the limiting, or at least not limiting, but is going to be the one defining how this algorithm is going to be, or under which condition is going to be usable. Because this data, we need to know how, or what is the approach or the elements that is covering. And finally, if we cannot understand step by step what the algorithm is doing, at least we need to understand, or we need to check that it's going to be functioning under the circumstances. So the testing is something that is very important. So the methodology is not enough. So what we propose is, okay, we have the methodology, but let's try and exercise it with different use cases covering the full chain. So from perception, understanding, decision-making, and traffic management. So result presentation. First of all, as I said, so first results that we are very proud is the methodology that is public, that is a document that you can find on the AIthena webpage, and how we have been proposing this approach. So we have gone through different documents, acts, standards, other activities from other sectors, how they are dealing with that, and what we have done is how we should apply this to the automotive mobility sector. So we have defined our own taxonomy on how to go through all these elements that are on a bunch of documents existing for trustworthy AI. And we have the pillar, and we have made a special effort on defining what transparency is. So transparency linked to explainability, and explainability for us is how to get an interpretable and complete definition of what's going on, and this we are linking to intrinsic and extrinsic. So by doing specific things in the algorithms to understand what is going on, and the second one is after testing that the system is well enough. So for that, we have created a methodology, which is a guidelines, guiding different stakeholders through all the process. So it's, you can see in the document, it's something like that, with tables, with questions, with explanations that you need to go through that. We are working with the FAME project to have an online version of it to make it more accessible to all the people that want to use the methodology. The second is, as I said, so we need to have a framework for defining what is going on, or how to get the accountability of the whole process. We don't want to be prescriptive with the framework because we understand that everybody has their own framework, but we want to have a guidelines by promoting this model car definition. By model car, we understand that with this approach, we can have the definition of what has been happening in each of the stages, which of the process has been handled by each of the stages, and we have complete accountability through the process. With that, we understand that we are covering the transparency and the explainability. And our model car is not something new. We have been using as a basis the Google approach, but we have enhanced and extended that to cover the requirements of the automotive sector. The third part, which is data. We have seen data anonymization in cybersecurity is something very important. Data is something crucial, and we need to capture visual data. Visual data, key. What happens with the GDPR? So we have been using the approach of blurring, but blurring alone and only faces is not enough because blurring is not sufficiently solid, and you can reverse sometime. And not only reverse, but is introducing artifacts that are not in reality. So if we want to use this data for retraining or testing or validation, these artifacts are going to be doing something. So what we are doing is, hey, can we take advantage of the generative AI? Okay, so what we are doing is a generative AI is very heavy. We cannot run it on a vehicle, but let's have two-step approach. Let's do in the vehicle something to have the knowledge of the pose and the elements and blur all the information as you are seeing there. And with the generative AI, in a second step, we are generating again humans, license plate, or whatever in order to use the data for training and validation. The next big outcome or approach is that we are proposing methodologies for developing explainable and trustworthy perception systems, not only based on the sensors and the algorithms, but having a strategy on how to integrate or insert intermediate layers for helping understanding what is going on through the process, and by proposing an interface for showing different types of information about the focus of the process, the different uncertainties and approaches. And we have been exercising that with sensors driving sensor fusion by fusing different type of sensors and approaching the whole process. For that, we have documented and we have exercised our model car and data car approach. And this is what we can show as one of the outcomes for using AI on perception systems, or at least generating trustworthy and a way that this perception can be somehow validating or certified. In the same way, the next main outcome that I would like, or the last one that I would like to emphasize, is how to use AI for decision making, okay? So the AI is very good at providing us different solutions, but not all the solutions that the AI is providing are usable or are the ones that we need to take when we are taking a decision while we are driving. So what we are trying to do is build comprehensible and robust stacks, software stacks for addressing the decision making, where we are using the AI on the first layer for trajectory planner. So we are letting the AI to propose trajectories. And then we know which trajectories or what are the limitations of the vehicles or the situation. And this is where we imposes a rule-based limitations to the outcomes of the AI, limiting the approach of all the possible solutions that the AI is giving and ensuring that we are only taking those that make sense for the given situation. And finally, we have an interface for the situational awareness to explain the process that we have followed based on a knowledge database graphs. So what we expect? What we expect is to have a mid- to long-term impact. So still, the project is running until November this year, and we are just involved in the validation and the use case validation phase. But for sure, what we expect to have impact in is by, thanks to this methodology, to have some kind of an harmonized approach toward the deployment of these systems, and helping and proposing new ways of adapting the actual validation and certification process in order to be able to handle this kind of functionalities and models. So we are in close contact with Head Start Sunrise Project to enhance how they should handle the AI approach when they are proposing their validation solution. And finally, so as I said, so the policy recommendation is one of the main exploitation or impact that we are expecting. And the other is that we are also generating data. We are generating data and models in our project, so our aim is to share that with the community. So we are in contact again with FAME. FAME is also developing a data space, so we are now building connectors to connect our data to the FAME data space in order to put it available, all this data that we are generating. And with that, I finish my presentation here. Thank you.
Thank you very much, Oyana. No, don't leave the stage yet. No. Because actually, I think one of the important aspects that you mentioned regarding the usage of the artificial intelligence is about the data anonymization, okay? Visual, I mean, taking as a base all the visual data, the perception systems that are installed within the cars, which actually I think is very useful for the GDPR, okay?
Yes.
Which is one of the aspects that we tend to forget, but it's a very important thing that actually is always, under discussion about how to protect the privacy of the let's say, of the environment. Okay, yes. Can you say, Chance, a few words about that?
Yes. So this approach that we are proposing is something that has raised attention, and we are actually collaborating with the HyDrive project, because the problem of recording data that is useful for the OEMs is a pain for them. especially not for the researchers, because we understand that if the data is coming and we need 8 seconds to process that, is nothing. But you go to a lawyer, and the lawyer is going to tell you, you cannot store for 8 seconds this data containing privacy containing information, because it's not allowed. For us, for the engineers, it's very, very difficult to understand that. So they are dealing with this situation, so they approach us. So the coordinator of Hydra project approached us, and we are in collaboration on how to integrate this solution into the Hydra project, just to ensure that we are going to be able to handle this with GDPR, and hopefully we can use the same for the large-scale demonstration.
Okay, thank you very much, Oriana. A big applause for her, please. We go now with our previous last speaker. The information that the speaker provided about the project that he's going to show. He says that the project contributes to be a CCAM enabler by proposing digital frameworks to link several scenarios, simulation, and user acceptance. It develops trustworthy artificial intelligence models for vulnerable road users and fosters collaboration to ensure ethical and socially acceptable automated mobility solutions, evaluating ethical aspects. The speaker, the project is A for CCAM, and Bon après-midi. The speaker is Loic. He's a research and development manager, artificial intelligence and data science at ERT System X company. You hold a Master of Science and Engineering in Artificial Intelligence and Computer Vision. You have experience in the research industry and skilled in machine learning, image processing, and systems engineering, among other things. And I found one interesting publication, which is you published in 2023, which is the Artificial Intelligence Engineering to Deploy Reliable Artificial Intelligence in Industry, right? I think it's a very important aspect, right? To exploit, okay, from the commercial point of view, or to integrate this into the industry.
Yes, aside of AI for CCAM, I coordinated a program which was called Confiance.ai, which was aimed to deploy in industry a system with AI inside, and this publication was a step in this direction. And operation is key for AI system. You just not have to design them, but you operate them, and how do you operate them and update them during their life cycle is key to have success.
Okay, thank you very much for the information, and I give you the floor to show the information of the AI for CCAM. Thank you very much.
So,
big applause, please.
AI for CCAM project is a sister program for AIthena, so I will try not to duplicate too much what has been said and provide any contribute and not to be too duplicate in the presentation. So first of all, the project, the highlight what we want to have in our project is we want to be able to provide framework to develop trustworthy AI for autonomous system. But we know that trust is not something we just demonstrate with figure or technical solution. We have to have user acceptance of this trust. So that's why trust, we try to make collaboration with people which evaluate how we can trust system, how people understand this system, even people who are not computer science, just a simple road user, and how they understand the demonstration of trust we can do. If I take the overview of what we have as an objective, there's 4 pillars. The first of them is we want to build a digital framework to make the link between the different tools, methods, and approach that we need to design a system for autonomous vehicles. And in such favors, methodology, I will not go deeper inside. We use the same thing that's AIthena, and we will collaborate on fusion for the end of the project with taxonomy with them. But we also know that we have to test. And to test them, we focused on scenarios. Which are the scenarios that are which have impact for vulnerable user, how we will test them, how we will generate them. And this is the digital part. The second part is how we evaluate with real user the impact of this solution and how we understand user acceptance of such solution. And on this thing, we establish an external committee to discuss with us about ethical principle. We make quantitative and qualitative understanding about what question user have about vulnerable user and automatic safety. So this was the two pillars which try to build a methodology which do not only rely on technical aspect, but also how people understand this technical demonstration. And the two other elements were we need use cases. Use cases is which focus we want to look at autonomous vehicle. There's user part, there's perception part, there's an acting part, and so we try to define 3 use cases to define this element. And the last part was to build a demonstration of this trustworthy at the end. So you have features that we have already achieved or which are under achievement. I will not go in the detail of each of them. I will then focus on several achievements and key elements we have in our project. The first is we think that we need a link from methodology, how we build a scenario from this methodology, and how we demonstrate an end-to-end trust demonstration. Because you can have a lot of small demonstration of robustness, of explainability, of uncertainty quantification, but how you put all these elements together to provide trust to final user or to auditor or to engineer who just build this system. So we have a link between the property at the end, a methodology with 4 big steps, scenarios, so how scenario contribute to all these 4 steps of demonstration. We build 10 scenarios with the tools which enable us to have an operational design domain parameterization of how to generate massive scenario for testing and simulation of real time. And then we have a digital twin to generate real simulation for this scenario to evaluate the AI system regarding these scenarios. So this is this path from how we go from methodology to scenario to use case, how we link all this together inside a path. Second thing I want to zoom is the digital framework. This digital framework just try to explain how we put all the pieces together. First, we have data set. We discuss a lot about anonymization, security, privacy, and we have this element inside. But how we augment, we extend, and we generate synthetic scenario from real data. So we start with real use case from open community, and we provide tools to extend them with adversarial training to find specific situation. We use generative AI to add data. We also use simulation with augmented reality to generate data for simulation between user and car. So with the scenario we have designed for car, we make the interaction between real people in test and this car on virtual reality. From this simulation, we connect it to the ethical point of view with question to people who make the test to try to understand how they feel when they interact with vehicle, how they want the vehicle to communicate with them, if it's autonomous, with some sign of the vehicle, etc. So we try to make the link between how they can trust the way the vehicle behaves in front of them. One of example I can take is what we find. It's that if the vehicle starts to accelerate too far, too strong after the crossing, they don't feel comfortable. Even if they are not at risk because they have already crossed the street, the vehicle just starts to accelerate. But the fact that it's accelerating fast after the cross makes them not comfortable. Next focus I want to do is on scientific contribution. So we do not work directly, even if we have model for the autonomous vehicle. We work on all the side models and tools that can improve or provide insight or property of trust of our model and components. So here you have several highlights. You have models which try to predict value trajectory in front of the car. So it's great to have a perception of the situation, but sometimes you need to have prediction about what will happen to maybe confront what the vehicle has detected. Second is explainability with a graphical representation of what is the situation around the car to provide insight about how the model interacts with the system. Last one is we discuss a lot of robustness. We discuss about, I would say, monitoring if the system is okay, but you also have to quantify the uncertainty you have in different situations because your system does not work everywhere at the same level of trust. And so uncertainty quantification about what you perceive and what you predict is a key element to decide if you can take an action. And the last one is use of generative AI to enhance your data sets, creating specific situations on real data, modifying them instead of just generating simulated one, because it's not exactly the same when you want to validate your system to have full synthetic data and real data just adapt. And one of very interesting insight on it was that we tried to discuss about, is it really important to generate data which seems real to the user? What we really want is data that seems real for the AI system so that we are sure that we detect. So for example, it was more important that the AI component detect a ball as a ball, but the humans say it's a ball. What we want, it's the AI system, not the human. So we do not try to focus too much on reality of what was generated, but something that seems real for the AI system we want to test. All of this was put inside a digital twin, which is shared amongst partners. I put also all the tools that were inside and technology we integrate in it. Maybe I want to emphasize on one point for this slide is open scenario and how we want to contribute to the description and integration of tools which enable to have a concrete description of scenarios, because standard version change, it's not always easy to have a good description. So we have models that we think will help to generate scenario in future from functional description of scenario to real instance and diversity in testing of these scenarios. On this slide, what I want to say, it's not only the autonomous vehicle. We have to take into consideration the user interaction with the vehicle which is on the road. So you have the system with all the models we discussed before. We have 3 use cases. 2 use cases which are focusing about the 2 functions which are embedded inside the vehicle, which is perception and action and how we detect person. And the second one is how we can perceive the gaze of the vehicle on the street, how we behave when he crosses the street, how we perceive the vehicle, autonomous vehicle in front of them. And we want to make reality check between the 2 ways we want to validate this system. And this is what is currently we have 2 experiences now with 2 cohorts of people which are testing this VRU and this scenario and this AI system. We hope to have a result at the end of the project. And all of these things are put in a participatory space, which is where we want to have feedback from users. We have interviewed with a lot of road user, driver, etc., to try to identify the proof we try to put in front of this demonstration, help them to have trust in autonomous system. Oh, sorry, I changed. At the end of the day, as from the previous project, we have a methodology with a lot of tests, with a lot of procedure to evaluate our use cases, and we will separate them in 2 of them. The tests which are static, which is just question that has to be answered by designer, but evaluator, but user, and things which are dynamic when we want to simulate them to have the real results. All these 8 scenarios are inside simulation. with use case 1 and 2. The virtual reality one are not video because we need people to interact inside, but we will have video at the end of the day. And that's what we will demonstrate for our final event at the end of the year. It's 17 or 18 November. But we are not doing this alone. We have a lot of interaction, so we share our result in several places from now, and we are discussing with them to connect our data set and our data generation tools to improve the data space already existing. We have started discussion with AIthena to share part of our methodology and to extend. As you have seen, there's a lot of similarity, but also difference and contribution that can be mixed at the end of the day. And we also have some relation to discuss beyond AI for CCAM and beyond just autonomous vehicle, because we are convinced that trustworthy in AI is just only a car problem. It's in all the industry, and so we start these elements. My last slide here is the two pillars we want to focus on for post-project and long-term impact. The first is dissemination inside our partners and inside CCAM communities of the tools we have developed. So we will propose a data set, an extension of data set we use with the new data generated, with new information, with new and certain element that we have compute of them to enable scientific community to work on this extended data set. We will try to provide extension of tools which are working on open scenario to make it easier to go from definition of scenario to real simulation. And also the participatory space, which will keep his life after the project. But we also try to find a way to have a community that's beyond the project, will continue to use what we have produced, and inside the CCAM, but also outside for the tools we propose to integrate them into framework or foundation that manage such kind of open source and assets. Thanks.
Okay, thank you very much, Lloyd. Thank you very much for the very for the very interesting presentation that you showed about the developments of the project. CCAM. You mentioned actually two important aspects. I mean, we have seen the cybersecurity, we have seen the data anonymization, but you also mentioned it about the user acceptance as well as the ethical aspects, which actually complements everything that, we have seen so far. What about the ethical aspects? Because it's also something, that is still, very controversial.
Yes, it's still very controversial. And if we are discussing about ethical, there's four elements. There's an ethical principle that we might fulfill. There's a norm, and then there's a standard that has to be compliant to respect this ethical principle. Then you have the methodology which responds to this standard, and then the tools you provide. And what we try to build inside our project is to tag from the tools to the methodology which contribute to what. Because it's very difficult to make the link between the two. In fact, we could not expect that when a scientist just tries to design a neural network model, he thinks about all the ethical principles when he does it. Second thing maybe I try to say is it's the way we design the system with the AI Act, which is coming, which is not only for automotive, but with intended purpose of the system. So you do not have only to define how the system shall behave, but what is the intended purpose of the automated function that you provide. And so this is this intended purpose, and I do not want to use the word because it was used before, but accountability of all decision of all people who have decision which warranties that this intended purpose is achieved at the end of a project.
Okay, no, thank you very much. I think it's very important, also to address that such kind of aspects. Thank you very much. A big applause for him again. And we go with our last speaker. Misa, yes, please come. The sentence that he provided about the project that he's going to show is the following one. The project contributes to be a CCAM enabled by delivering a weather-resilient embedded in-vehicle perception and decision-making system for connecting automated vehicles. This helps to accelerate the implementation of artificial intelligence-based innovative CCAM technologies for passengers and goods. The project that you are going to show is ROADVIEW. Let me try to pronounce it. Good eftermiddag, something like that, right? So the speaker is Erden. He's associate professor at Halmstad University of Sweden. He worked on creating the semantic representation of visual experiences to achieve a better environment and action understanding for autonomous systems such as robots and unnamed vehicles. You hold a PhD on mathematics and computer science, and maybe I'm wrong, I don't know, but you hold also a doctorate in philosophy.
No.
No? Okay, so the information I found is not the correct one.
So we should not approach ChatGPT always.
Okay, no, but I found it in somewhere, you know, in the profile. So either someone cheated, you know, you or you, okay. But, well, in any case, you have 15 minutes. If there is some question that can be addressed, you know, by the rest of the others, they will do it afterwards, and you can now proceed with the presentation. Thank you very much.
Thank you.
A big applause for him, please.
All right, as the last speaker of the last session, I will do my best to entertain you and also try to keep you awake. I'm gonna do my best to introduce the ROADVIEW project that I'm honored to coordinate. ROADVIEW stands for Robust Automated Driving in Extreme Weather Conditions. Just to make the picture crystal clear, in this project, we are not dealing anything with L5 driving. We do not promise anything about L5 driving. What we are after is like, how can we make those vehicles running under bad weather conditions? Because I'm pretty sure you have seen those fancy videos on YouTube, like those that are running in the sunny California days, like from Waymo and so on. They're fancy, no question about that, but I can't take them to Sweden under bad weather conditions. No ways, nothing will work. You can also see quite some videos on YouTube, like how Tesla fails under rainy conditions and so on. So this is exactly what we are after. All right, so just a brief overview about the project. We have like 15 different partners from 7 different European countries. It's a 4-year project, and we are like right in the middle of the project. So we have about 2 years to go with the budget of 10 million euro. As you can see, we are covering quite large area in Sweden, in Europe, and we have those 4 different vehicles. And one of them is only for logging, but the rest are really for automated driving. And this truck is, for instance, L3. Now we are trying to achieve L4 with that one. All right. What is our objective? So ROADVIEW is actually addressing the weather-related challenges like harsh rain, harsh snow, or fog even, by developing robust and cost-efficient embedded in-vehicle perception. So whatever we are going to propose should be cost-efficient. So we cannot come up with a solution that cannot be deployable or that is not profitable in the short term. And a system that is weather-aware, making decisions based on the weather. Like if there is any snow, maybe you should decide autonomously that you should slow down, not to have the slippery effect. For connected and automated vehicles with enhanced performance under harsh weather conditions. And connectivity is also involved because we are having V2X communication where the infrastructure is helping the vehicle to survive around. And we have 3 pillars here. As other speakers mentioned, we are also willing to have a simulated environment where we can generate data for free. But there is this sim-to-real gap. Whatever you are generating in the simulated environment is not applicable to real world. So this is why, as different than others, we are having the second pillar. So you have the control environment. We have real rain tunnels, fog tunnels in Germany, France, where we are introducing a different amount of rain and fog with those controllable parameters, which is great to bridge this gap. because then you can validate your noise models before deploying your solutions to real vehicle, so that you can then fine-tune your solutions with real data coming from the third pillar. And then we have perception solutions, which are to some degree explainable, and also we have control mechanisms which are taking information from the weather. And we promise to have some demos trying to achieve TRL7 because the innovation and action call. Right, so the ultimate aim is to close the important research gaps and collecting data from different operation design domains to move towards systems at TRL7. All right, this is just a brief overview, and now I'm going to do, what I'm going to do is I'm going to show you some results from different pillars. Okay, starting with the very first one, we have this simulated environment where it's a parametric simulator where you can just change the parameters to introduce different amount of snowfalls, and you can actually change the vehicles, you can change the other weather aspects, sliperiness on the road surface, and so on. So you can play with the dynamics, which is open source and available, developed by one of our partners from Finland. And we also went one step further and developed digital twins, for instance. So this map is actually showing you the demo area. So we have to demo we have one demo in Germany, one in Turkey, and so on. But another, or the most important one is in Finland. We have to go to the North Pole, so we cannot escape snow there at all. So we have to show that the system is running under real snowy conditions. And this is the Lapland playground. It's one of the very famous areas in automotive industry because almost all vehicles are going there to test or companies are going there to test their solutions. So we created a digital twin of that environment and pass it to the playground so that now they can share it with the other stakeholders. We also created digital twins of our own facilities in Germany and other places. This chapter is over, and when it comes to pillar 2, where we have the control environment, this is actually one of the experiments that we had, and we're about to release the data set because this is one of the first in the world, where we are using automotive-graded sensor ring. All right, here. No, let's go back. All right, this is our sensor ring. We have LiDAR, radar, camera, and thermal cameras, and all of our automotive-graded. That means you can actually deploy them to your vehicle. And we did a set of recordings, where we, by using those sprinklers, there are a bunch of sprinklers here, and you can change the amount of raindrops there in different intensity levels. And what we did is we used automatic labeling tool, benefited from AI. We now labeled every single point here. So you now know where are the raindrops. This is fundamentally important if you want to mathematically model the raindrops or fog elements or snowdrops, if you can manage that. So we use this information to validate our sensor, our noise models. And this table is actually very important for the research community because we are the only one that is giving very dense point cloud coming both LiDAR plus 4D radar. So the radar that's also giving you point cloud data for those who do not know the field. And it's full annotated. You can use it for training AI models, or you can use it for validating your noise models. Okay, this is open for public. All right, so we move forward. Regarding the third pillar where we have the real data, we have this vehicle, which is only for data logging. It's not doing any automated driving, but we have actually a sensor, interesting sensors here because, you have a high resolution LiDAR 128, and also you have RGB cameras, thermal cameras, but you have also this guy here, which is a Vaisala sensor, which is actually predicting the road grip surface parameters. And we use this thing to train a model that can predict the slipperiness of the road surface. So on the top, you see those dots, which are coming from this small sensor. It's just giving you local information, slipperiness information about the road surface. What we do, we are fusing camera and LiDAR here and extrapolating this information so that it can predict the slipperiness for the remaining part of the road surface. Plus, it can also give you the confidence score, so how confident it is about its own prediction. So because we are talking about safety-critical applications. And it's a fully snowy case. So there is a case where you can now see, like if you have high lightish, yellowish area, that means it's highly slippery. Plus, if you have also a light color here, it's like it's very sure about its own decisions. Okay. And there's another work that's coming from my group, actually, from Sweden. I'm very proud of saying that we have developed the fastest algorithm in the world that can clean the point cloud data. So here, I just show you real LiDAR data coming from real vehicle. So it's a LiDAR 64, captured in Michigan in the US. And those black dots are snowdrops. If you use our algorithm, you can actually remove all those snowflakes and have very clean point cloud data, which can be used for the downstream tasks like object detection, semantic segmentation, you name it. And the beauty of this thing is that our algorithm works in a fully unsupervised manner for the LiDAR, for the snow points. That means you do not have to go and annotate points because this is a must for supervised AI algorithms. And we are improving the performance of the literature works by 6% by this algorithm. It's the fastest and the most accurate one. And you may also say, why is that important? Because this is one of the most important innovation solutions coming with the ROADVIEW project. It is because we show that if you follow this scheme, like first take the raw sensor data and filter it out, you can actually improve the downstream task for free. So this is what we show here. So you use any kind of state-of-the-art semantic segmentation algorithm, let's call it Cylinder 3D, which gives you some accuracies. And after applying our algorithm, if you repeat the very same thing, you actually improve the performance by 5% for free without retraining anything. And it is super fast, so there is no latency that you are introducing to your system. So you can still run in real time. Another beauty is that if you go one step further and run object detection without having any additional data, you can actually improve your performance, if I'm not wrong, by up to 2%. So it is very important to first understand or to clean the data before feeding it to your downstream tasks. So this is very cost-efficient solution coming with the ROADVIEW project. Another super interesting work that's coming from our partners is this V2X-based minimum risk maneuver control. So here we are talking to the infrastructure continuously, and we have a scenario where the vehicle is moving autonomously, but all of a sudden there is a pedestrian or fake pedestrian recognized, and by using V2X communication, we are triggering the control algorithm so it can go to emergency stop by finding the shortest path to the safety shoulder. So here the vehicle is actually running autonomously at 50 kilometers per hour, but by getting the triggering signal from the infrastructure, it can find a path nicely, slow down, and go to a safety shoulder, which is quite important because meanwhile it is changing the speed of the vehicle itself. Okay, so far so good. Those are the results, but we still have 2 more demos that are supposed to be delivered by end of August. Hopefully next year I'm going to show you more interesting demos, results. But what's coming very soon is very interesting, this data set. This is one of the first data sets in the world captured under snow and coming with both semantic labels plus bounding boxes. So there is no data set, such a data set in the world right now. And we are really pushing the boundaries by giving this data set to the community so that they can validate their advanced state-of-the-art algorithms. And we are doing benchmarking currently, which is showing that the state-of-the-art results trained with this normal clean data is not working here at all. So you have to really go one step further, which is coming very soon in a month, I will say. And again, we are going to deliver some demos in the next 18 months. So by end of August, we are going to have a demo with this truck in a highway scenario. And we are going to also have one demo in Germany where we are showing how to validate our sensor solutions, like vehicle-in-the-loop, sensor-in-the-loop solutions in a controlled environment. It's very interesting. All right, mid to long-term expectations, expected impacts. Meanwhile, I forgot to say that we are also about to release our policy briefs. We are almost done with them, so we are willing to give some feedback to the policymakers because right now this weather aspect is totally omitted, so there must be something that we have to take like an action. Regarding the key impacts, this table, I know it's pretty small to read, but I will do my best to summarize. So we are somewhere here. We still have 2 years to go, but once we are done with the project, in the very short-term period, we expect that at least our solution should be deployable to one of our vehicles. In the bit more midterm aspect, we are willing to see that the community is using those data sets. and there it's very appreciated. And also, we are willing to make a product out of some of those innovations coming with the ROADVIEW. And the long-term impact would be like having the social acceptance of our solutions, because there's also this barrier. Whatever you present, maybe it will not be accepted by the community. With that, I'm done. I still have 1 minute, but I would like to release this video which is actually taken by a real vehicle. And those black dots are the snow particles, and as you can see here, it's nicely cleaned, and the other parts are not cleaned, so it's also important. Thank you very much.
Please, thank you very much, Eren. I'm actually very much looking forward to seeing the final results, because I mean it's very impressive information that you show with. I mean, as per the perception sheets and how do you take the decision making, that's going to be taken by the system while they are facing these extreme conditions. It's very, very interesting to know. I don't want to absorb most time because I think that Margriet is going to kill me because we are almost there. So thank you very much again, and I pass now the floor to Margriet to start with the Q&A session. Thank you very much for your patience. For your patience. I give you the floor.
Perfect. Thank you, Pedro. Well, thank you. I think referring back to the Cluster 5 from the CCAM partnership, which is on the key enabling technologies, that aims for the development of enabling technologies driven by digitalization and extending the application of these technologies beyond also the individual vehicles. And as it is also in our research agenda, it is a major key to develop and trust user adoption of CCAM solutions, that we really have safe and secure operation of CCAM services and solutions. And I think in this session you have seen all 4 projects having a very clear ambition and a good motivation to deliver to that need. I think we have seen a very nice toolbox filled with a lot of tools, macro tools and also smaller tools for resilience, for data management, but also the system requirements for such tools. And we have seen also very firm contributions from 2 projects on trustworthy and on explainable AI for CCAM. And very important, because those terms do exist a bit longer, but also with sector-specific knowledge and sector-specific use cases. And the translations of those technologies to our sector is not that easy. You can have seen that there are still some struggles and questions and things to be solved. But it's good to see that we are making steps towards there. And of course, the approaches and tools to tackle challenges of driving under harsh weather conditions, because it can't be California everywhere. Luckily, I hope, really. And guidance also to, for instance, a minimal sensor suite for this. So I think so far we have seen quite diverse topics, and I've had the honor and privilege to see a bit more of all of these projects. But for some of you, there may be still something fairly new. So there is the opportunity to ask these people any question you like about the projects. Yes. Well.
Thank you very much, João CINEA, for Loic. You mentioned uncertainty quantification. Normally, at least to my understanding, and correct me if I'm wrong, uncertainty quantification can be used to optimize tools, and often you obtain a trade-off between peak performance and robustness of your tool. This is okay if we are talking about, let's say, predicting the temperature, where you might get a difference 1 degree in 1 day, but overall in the week you get a better prediction. But how is this, how can you deal with this on CCAM, where the consequences of failure are very dire?
Depends on uncertainty quantification on what? If it's on a value trajectory future, maybe you have a good confidence on the first 2 or 3 meters, and then it's fade off during the time. So if you just plan the trajectory, you don't know if it's true or false, and at least you know that it will be fast, maybe in 1 or 2 or 3 seconds. So you have to identify the certainty you have inside this prediction. So sometimes trying to predict the real value of things is not the good things. You have to, what is the medium prediction and what is the variation around I can expect. It's something which is more useful for decision algorithm above this perception system than just trying to find the good answer. So it's a trade-off between robustness. I'm robust to such perturbations, so I guarantee the results. The quantification of uncertainty, which help monitoring to take decision to rely on this sensor or the sensor, because if you have two sensors, which one with a high level of uncertainty and the other with a lower one, you will take the one which has the lower one. So it's help you to decide on integration of different components.
Thank you. Thank you, Loïc. Then without the microphone. Any further questions?
So just to put it out there, so we saw for all the projects, so your test cases, maybe the one a bit more different was the one on extreme weather conditions, but the other ones, it was parking lots, streets with not so many people. So these algorithms, these demonstrators, they work well in, let's say, Northern Europe. Now, if you come to where I come from, to Southern Europe, where, let's say, driving habits are a bit different, how difficult is it to extend such models to complete different driving habits and narrow streets, motorbikes coming and going?
Aaron? Yes?
All right. So I'm not that optimistic about that. The thing is that there is this domain shift problem. So whatever we propose here are really working for some certain conditions. This is why we call them ODD. In these given certain conditions, it will work to some degree. And scientifically speaking, we are repeating the experiments quite a lot so that we can come up with those numbers in the KPIs to make it more realistic. So we give you quantitative results as well. But when you switch to another domain completely, I don't think you'll be impressed at all. It is because domain shift is a known problem. It is already there. It's not something that will be discovered today or tomorrow. But the thing is that none of those projects are dealing with this kind of problem. So we have to first, let's make sure that we can solve the problem in this specific case. Let's say in Sweden, can we drive under snow? If we achieve that, then we can talk about this switching the domains, and because it's going to be relatively easier, because you have already some sort of knowledge, prior knowledge, solutions to your problem. Then, based on that, you can, extend your information solutions to adapt new ODDs. But currently, I'm not aware of any work that can handle this domain shift problem.
I think, Oyana, you were trying to get into the microphone as well to get to this question, right?
Yes, but it was aligned with what has said. So it's that the cake we need to eat it in pieces. So first, we should focus on solving first problems and then doing this domain shift. And also the domain shift is also linked to the operational design domain of the functions that we are allowing to put or to deploy on the roads. So we know that the technology has some kind of a limitation. So when you are deploying something, you say under which condition it's going to be working. So, for example, the uncertainty is also important because if something happens and you see a great uncertainty in one of your sensors, then you know that you are not matching the operational design domain to which this function was designed for. So you need to switch off because it's not any more reliable. So the solutions that we are doing today are somehow limited. We know that, and we are trying to extend the operational design domain. We are trying to extend the technology approach to these domain switches, but we go step by step. So for the moment, the operational design domain is somehow limited to some specific situation, but this is what we are trying to do within the projects.
Thank you. Any further questions? Yes, Ted.
Maybe not a question, but last year we finished the award Pedro, I hear you. We finished the award project, which was all-weather autonomous real-life deployment. And I find a link with ROADVIEW there. And we also had some policy recommendations for more deployment, etc. So maybe something to have in mind and work on the results of pre-existing work.
Sure.
Thank you.
Thank you.
Thank you. You don't always know that those documents do exist from other projects, so it's good to be made aware of it. Thank you. Yes. So it's good for my... Yeah, you are having a good question. I'm quite sure about that, Mark.
Yeah, hi, thank you. I'm Mark. I'm with RDW, it's the Dutch Type Approval Authority. And was quite interested in this session. How scalable are these solutions? Also the roadside units and also the other solutions. So I'm curious. Scalable and yeah.
For roadside units as well to be used there. Good question.
Yeah. Yeah, I talked something about the scalability because for us it's quite important, and I was not only mentioning the vehicle side, but also the infrastructure side. Yes, the scalability will depend also on the quantity of sensors and roadside units that we have on the road. This is one point. From the other side, the scalability is not, to my opinion, only depending on the level of penetration of high-level CCAM. Because at least for the cybersecurity part, we could already work quite a lot with the connected vehicles with lower readiness. So this is really good. But coming back to the infrastructure, for sure we need to have more information. As you have seen, the system is learning, and as many data that we can get from this infrastructure, roadside units, smart cameras, and so, of course, it will give more robustness to the system. So we are now here. The next step would be to try to upscale, but it will depend on the infrastructure investment that we have in the different sites.
Any other of the speakers willing to take this further?
Maybe I can also comment on that. Yeah, scalability is $1 million question. We are very aware of that one. So the way that we want to answer this is like having demonstrations in different locations. So if you come up with a one sensor setup that works in, let's say, in Finland, can we use the very same setup for another passenger vehicle in Germany? Or can we use the very same setup for a truck? The answer is no. So by showing the solutions in different ODDs, we want to also indirectly answer this scalability question. In the project, we are not targeting this keyword as it is, but indirectly our solutions will give us an answer, or the landscape of the scalability, saying that even if you change the sensoring for the very same vehicles, maybe sometimes it will not work for some reasons. If it is so, why is that the case? So we want to answer this, which is scientifically very interesting question, by the way. Thank you.
And before we open another can of worms, because there's still a lot that we need to explore. We're not there yet, but I think we are gradually moving really in the right direction. And I also heard that we are making steps towards, maybe not yet deployment, but making next steps, as you propose, Fanny, to go towards the large-scale demonstrations and use the toolbox there, for instance. So we're gradually moving there, very nice. But I also see that we're gradually moving to the end of this session, because in 14 minutes there is the closing session in the auditorium. And I'm quite sure that the speakers, Jane Amilat and Simon Edwards, won't appreciate it if I keep you in this room. So please join me in thanking the speakers and also Pedro for organizing this session. Thank you very much.